to show this on the microscope, although it is not the cheapest system, but it is more convenient for us to explore and to visualize.
What microscopes can you be adjusted to?
Any microscopes, any commercial microscopes. The only thing we change is adapter joining our Raman model with optical branch of microscope. It is like it's like free. It's very cheap, and it has the difference is only in diameters of flanges. The different microscopes. For us, the difference is only in the diameter of flange to secure the Raman model on the surface or on the microscope. So anyone, Nikon, Olympus, anyone.
Okay. So, but in my acknowledgement, it has to be a infinite optic system. I mean, this should be a how to say, the light here should be not like this.
I have never seen microscopes with intersecting optical branches. What does it mean?
I mean, there are some microscopes with this kind of system, which in this part it is not parallel.
It's not in parallel beams.
Yes. And the last
you mean that there are microscopes working with convergent beams, right?
Yes.
Okay, our device is designed for using of infinitely corrected.
I said in my acknowledgement there has to be 2 points to check if one is if there's infinite system, and the second is if there's anything like a beam splitter in this point, which cannot be maybe.
It can always be added to the optical branch of any microscope. It's like an adapter which can be removed or added. So it's not a problem, even if manufacturer doesn't provide standard beam splitters and standard adapters, we can put our microscope in a trinocular hole.
Yes.
Our Raman model, to a trinocular hole, and it will work as well. As I understand, any modern microscope has binocular along with trinocular to connect video camera, for example, and it will enable us to build our system in.
The last time we went to a microscope, metrographical. So it has some sitting on this point, and the beam splitter cannot be removed.
Cannot be removed?
Yes, cannot be removed. So the laser would be if we add the Raman spectrometer here, the laser would be we have to cross the beam splitter.
But what is it used for? What is it? Why do we use mixsplitter? For what purpose? For lighting of a sample? Or? what is the you said that you've seen a microscope with beam splitter cannot be removed, but why did we use it? Anyway, if there is any beam splitter, we can always mount our Raman module to look inside this beam splitting system and to direct our laser beam along the optical axis.
Okay, wait for a minute. I'll take my laptop.
Illuminating and will not be removed. It will be okay to have it inside. And we will also put our second beam splitter for Raman module.
So it means the laser would be how to say it?
The laser would be reflected downwards,
Yes.
and will pass through the first beam splitter.
Here.
Yes.
So
And it will be reflected back.
the signal would not be reduced too much.
Not much, because beam splitters, especially for illumination purposes, they reflect no more than 20%.
But
I mean, yes, we transmit about 80% of light, and
yeah.
okay, we will lose signal, but about 40% at all. It's not a problem. Of course, any reflecting surface will reduce our signal, but if it is reduced by 40% or 30%, it's not a problem. It will not prevent us from seeing Raman spectrum. And as I know, what is the model number you say?
BX41. But it is not a bio. It is not the bio microscope. It is the industrial microscope. So the framework would be different.
We could look at drawings of this model in the internet, because I need to know whether this part with trinocular is can it be unmounted from yes, can it be detached like in this model. And as far as I know, in Olympus they have all parts of microscopes separately and connecting via its triangular connector. Do you know how it looks like? It looks like assembly flange like this. And all parts are connected using this assembly. As you see in this model, we can detach the trinocular module from beam splitter and from frame, microscope frame, and I believe in BX41 we also have similar construction. That should not be a problem. I also know that BX51 we have once modified BX51 microscope of Olympus, and there were no problem. Sasha, вопрос. Could you ask this question to our microscope specialist?
Hello, my name is Alma.
Hello, Alexander. Hello.
So my question was initially about what can, if we run into a microscope, what should I check if I can make sure it is fit for the Raman spectrometer? I don't.
чем дело про BX?
The main point is that between laser, between our device and microscope objective should not be any optics besides of our beam splitter. Here we have beam splitting cube.
Yes.
And no glass, no optics in between.
Not even another beam splitter.
No.
Okay.
Because you will have additional reflections of laser, parasitic reflections. You will have also some loss of useful signal of light from the sun.
Okay.
That's why we prefer to have no other optics between our device and objective, and here only single beam splitter.
Okay.
For example, at your microscope you have here one beam splitter which we cannot use, and we cannot remove it. Or if we remove, then you will lose opportunity of reflected light illumination. Here you have LED, as I understand, as a light source, and here some beam splitter is mounted.
Yes.
Yes, it's transparent, and some part of light from the objective, from the sample, it will pass through. But I cannot give any warranty that we will not have additional problems with our useful light. And besides, we need to focus our laser beam, we should avoid any additional optics.
Okay.
That's why we either use this kind of microscope, or I can show you also. Yeah, this is also Olympus, but this is Olympus DX51. Here you have reflected light illuminator, but
This can be empty, I think.
yeah, here you have revolver, with cube beam splitters, and you have 6 positions to use different kinds of cubic beam splitter for different purposes. You can simply remove one of them.
Yes.
And then, and again, you see the same geometry. Our device here, cubic beam splitter. When you push the lever inside, it's inserted to the beam path, so the light from our laser passes through, comes to the objective, to the sample, and then the scattered light comes back, passes back. And with the help of the same cubic beam splitter, comes back to our spectrum analyzer. And here, by revolving this this unit, we can avoid any glass part, any optics between our analyzer and the sample.
To identify components of powders, like in medicines, pills, and the specific procedure, it requires sample preparation. It requires powder to be applied on the flat reflecting surface, like this substrates covered, glass substrates covered by aluminium foliage, aluminium scotch, or anything like this. It could be just a flat metal surface, but the cheapest and easiest solution is glass covered by aluminium foil.
So just glass would not work?
It would work, but glass also has some weak Raman signal.
Okay.
It is located on the left side of the spectrum, no more than 1,000 reciprocal centimeters, but and you will be able to see organic Raman spectra overimposed on glass. But I think it is it's worse because you will not have clean and clean spectra. They always be overimposed. And also, metallic surface was chosen because it reflects Raman signal and doubles the signal output of our measurement. Imagine you have Raman signal passing in all directions, upwards and downwards, and in case of glass surface we just lose half of signal. And if I use metal foil, it will reflect everything. For example, we can start from the beginning. Take a multi-component tablet. It's called Cafetin, if you know it. It is a headache medicine. It has paracetamol and caffeine and some medicine, I don't know, it is called propionazole, but I'm not sure about its properties. We hope to see 3 components in the results of scanning, but before we start, I need to triturate the some small piece of tablet using this flat metal surface pounder. Ideally, the powder of the microparticle size should be the smallest possible, because it will easily adheres to the surface, and the particle size will be just as the laser spot diameter, about few microns. And you will be able to measure every time a separate particle, and afterward we will have rich statistics of spectra recognized separately. It is enough. This surface was wiped, has been wiped with ethanol, just to remove any organic particles, and probably dyes and fat.
Yeah.
Or we can do it once again, just to show you. I take cotton disc, then wipe it. Have something on the surface. In principle, even just trace amount of powder particles is enough for recognizing. Like this, you see the surface is not covered completely. There are just some microparticles, and we put it under the objective.
So in this way, the spectra of every point will not be a combined
When,
spectra.
yes, they will be separated because we have strong spatial resolution of our system, and every spectrum will be taken from different spots, from different particles. I prefer looking on the surface with illumination and see how the particles are distributed all over the surface. So, in principle, they are isolated, and when we turn on the laser and move with steps, say 10 or 20 microns, we will have reasonable statistics of different particles. As with mapping, I also use this curtain to protect from light. And there are some other recognition parameters which were not applied in the software of mapping. Scanning, the main parameter is number of steps. Typically, it should be more than 300, 500 steps, because some of them will be empty when laser spot is outside particles, and that's why we need to have more statistics. Exposure time it can be chosen automatically, but normally I prefer to use overall exposure less than second. It is enough. And we need to specify a directory to save all the data, including the results of recognition and the raw spectral data. Okay, and I will better. We could check this begin recognition after scanning, but I prefer to recognize separately because there are too many options, settings for recognition. You will see now. I will better explain them after we finish with scanning,
Okay.
because these parameters include a set of numbers for individual spectral recognition, like those shown yesterday by Andrei, and also the parameters for recognition of groups, for combining spectra with each other to groups. I will explain you while it is scanning. I will explain you the algorithm of recognition. Okay, let's do it after recognition. It should take about 7 minutes. And so, what is the difference between recognition of separate spectra and of this large amount of different spectra, about 500 spectra? It would take quite a lot of time if we recognize them separately. That's why we we decided to combine spectra with each other by mutual correlation, by mutual resemblance. And after we have some separate groups of identical spectra, we recognize every group using database. So before we recognize spectra, we combine them in several, like 10 groups with containing just similar spectra, and then we use the standard recognition system or the whole database.
What about if there happens to be two components in one spectra?
Normally, if two components are 50 by 50%, the result of recognition will be less than a threshold, recognition threshold, because none of them will exceed the threshold value, and this spectrum will be thrown away. And if we have if you have sparse distribution of particles over the surface, the probability to meet two particles into micron spot is negligible. You know, it's very low because we have high resolution, and average particle size is 5 to 10 microns, but the laser spot is 2 microns in size, and it is almost impossible to see the combined the overimposed spectrum. Let us start recognition. I just want to show you, explain you some of the parameters used here. It's more complex than in standard inspector software. Okay, first of all, minimum match means the threshold value of correlator, which enables us to identify or to throw away the spectrum with correlation value exceeding or less than this value. For example, before identification or putting the result of identification to the list, it always checks whether we exceed or not this threshold value. 3 or 4 parameters here are the same as Andrew was showing you yesterday. Lines dynamic range, which separates, which gives us the range of lines to be checked in the epsilon spectrum and measured spectrum. Lines threshold, auto slope, it is correction for different spectral response, or more important, to correct for some possible deviation from lines intensity in database or and in measured spectrum. It may be different because database was combined from spectra taken on different devices, our devices, and from outsourcing using our equipment. The same is auto shift, which enables to adjust the position of Raman spectrum as a whole to maximize the correlation with epsilon spectrum. It's exactly as was explained yesterday. When search groups.
I have a question about the shift, auto shift.
Auto shift.
Yes. Why is it percentage?
Auto shift. It is in some arbitrary units.
Oh,
I agree that persons is not the most suitable units, because Andrew yesterday showed me that it could be more than 100, right?
yeah.
It could be 200, or it is. I think persons here is just old. Is taken from old implementation, but really it is in some. Yes, it is in persons of the line width. I remember it is taken in persons of the spectral line width. If we have, for example, laser line width of 5 pixels, 5 pixels, the auto shift will be in the range exceeding this twice. So plus minus 5 pixels from its central position. It can shift the whole spectrum in this range, okay? Because the option of auto shift is applied only due to some possible shifts of laser line from its nominal value. The nominal value is 532,
So this
and
is
it can
like
be shifted.
the shift relative to the peak
Relative to the
peak width itself.
Yes. First of all, it determines the peak position,
Yes.
like a maximum of that curve,
Yes.
and this peak position can still be shifted from its actual value, because the laser is too strong, and when it inserts the Raman analyzer, it can be distorted, right? Distorted somehow, and it can be shifted on the CCD surface. That's why we know that the actual peak position, actual laser position can be shifted by approximately line width. That's why auto shift is measured in persons from the line shift of a laser. Okay, it is just optical. It is artificial effect of focusing of a laser beam on the CCD surface, and the auto shift value is set as empirical. We know it should be about 100%, or no more than 100% of the line width. Then we have several parameters like search groups. It is a number of groups to combine identical or similar spectra. For example, we have 500 spectra. Some of them correspond to one substance, some other group to other substance, but within this group, the noise level and background shape, they can change. That's why even spectrum of paracetamol, it is different one from each other, and before combining them to a group called paracetamol, we need to compare them with each other, and if their mutual correlation exceeds threshold value, they would be combined. And after that, when we have separate groups, like 5 or 10 groups, we recognize them and identify them using database. Now we can try large number. It will not take much time. Filtering window and filtering threshold, auxiliary parameters used to distinguish between Raman line spectrum like this and noisy background and noisy
Luminescence.
Yes, luminescence, because some portion of our measured spectra have no Raman lines at all. They are just empty. They are taken from empty areas of the sample. They look like background or fluorescent shape, and we don't need to recognize them. We just need to throw them away. And these two parameters are used as a criterion for separating Raman spectra from background. Unknown separation, this is a parameter. I'll explain. Okay. We analyze and don't know whether we have all of the components in the database or some of them are absent. But anyway, if we recognized some components and identified, we will show them. But we can also meet spectra which are not in database, which are absent in database. But anyway, they are Raman spectra, and we know how to separate them and how to distinguish them from background. We need to include them in the result table, but we will have to call them unknown. But unknown spectra can be all the same or can be different. Imagine you have some medicine with 3 known components and some impurities, but you don't know what kind of impurities, and possibly the database hasn't got this spectra. Or even the situation when some synthetic narcotics, they are produced every day with modifications, with some chemical, with extra chemical groups, which may not be present in our database because they are freshly constructed. But still, we need to show the results that we found not only identified spectra, but some new or some unknown spectra which need to be treated somehow.
So this parameter is to decide whether this identified spectrum is or is not a Raman spectrum.
Let me explain you further. If you have one or several groups not identified by your database, they are treated as unknown, right?
Yeah.
But they could differ from each other, and this value, this unknown separation value, is a threshold value of mutual correlator between these unknown spectra, unknown groups. And if their mutual correlation is higher than this value, 90%, then they will be put to one unknown category. And if their mutual correlation is below this threshold, they would be called separately unknown 1, unknown 2, unknown 3, okay. And you will know how many impurities, unknown impurities you have in your sample. Okay.
Okay.
And synonym clearance is also used. Synonym clearance is has a different meaning. It's just for convenience. For example, you have a big database with almost identical spectra like sugar and glucose and some isomers called differently. I'm not strong in chemistry, but you can imagine that the same spectrum, the same substance could be named differently.
Yeah.
Like like a common name we use in life and some chemical special name, but the substance is the same, and we need some criterion how to combine the identical spectra and not to call the same spectrum with different names. For example, we have results with 5 different names of glucose. One of them is alpha glucose, second is lactose, I don't know how many synonyms, but we need to combine them with some criterion. If they correlate with each other, we give them the same name, one name. Okay, but this is just for convenience. We could avoid this parameter and to call the same spectrum with different names in the results table. It's not crucial. And the categories to recognize, we can check one or several of them just by double click. We can select any categories or full database.
Yes.
Full database normally takes more time. That's why I have specially prepared categories with pharmaceuticals. And that's all. And also I forgot to show you parameters of scanning, like step size, like how many spectra we skip after move, like it was in mapping software. Again, we due to the memory effect of CCD matrix,
Yes.
we need to get rid of wrong spectra. Normally, first spectra at new position is wrong because it has some implication from the previous spectra, and we need to throw it away and measure and skip the first and measure the second. Components, some of them are unknown. Main component is paracetamol, which is really the primary. Caffeine, it should be about 5% in the, nominally it is about 5% in the medicine, but it shows a bit less. And it is due to the statistics. So if we are ready to wait longer to record thousands of spectra, we would have quantitatively exact results. And if we just need to have approximate values and qualitatively determine the components of mixture, it is enough to scan for 5-10 minutes. My experience follows that this device, it gives reasonably good qualitative results, but quantitative results, they would require much more time.
Okay. So,
especially if we are searching for trace impurities, very low numbers, low percentages of impurities, we cannot consider the results as exact, because from 300 spectra, for example, we got just 5 or 6 spectra of caffeine, and the statistics deviation for small numbers is very substantial. But if we would be able to wait for 2 hours, we would have 3 times, 4 times more spectra, and the statistical deviation would be much less.
okay. Into this step, can we, if I may, let's say, if I think the blue, the unknown 2 or unknown 3 is cafe, may I combine them?
Yes, you can combine, and you can also, I forgot to say, you can also export them to the inspector software and use other databases, other categories to recognize them separately. You can also save them and send for recognition like this. The combination of unknown spectra, as I told you, is it makes sense when their mutual correlation factor is more than, I don't know, 80–90%. But if it is lower, this threshold value, they are treated as different unknowns. Because indeed spectra are different, but they could differ from each other by noise, just by noise, or by line positions. We should have some compromise threshold value to distinguish different spectra with different line positions from just noisy variations of the same spectrum. Here, I think we have a case with different spectra of different noise level. That's why we have quite a lot of unknowns.
Another question is about the search group you mentioned. This parameter, if I set to 5, would the value be thing in this?
If you set it about 5, you will have
Only
overall number of substances less or equal to 5.
okay.
Let's check it. Search groups, and we can also change the non-separation threshold to reduce number of unknowns. Let's see what happens. Now, I believe we should not have too many unknowns because the overall number is 5. But I forgot to say that while scanning up to 30 minutes, we can find impurities like 0.5%. I checked the abilities of this device, and while I was preparing powders by myself, I took small amounts of impurities, added them to the tablet of clean, one component tablet, and the minimal value I was able to find was about 0.3%, and the scan and the time required is about 30 minutes.
I think on Maxim's slide, the PPT, he mentioned it as 0.5 in 20 minutes and 0.1 in 100
That is close to,
minutes.
yeah, about like this. I told you I got 0.3% for 30.
Say,
But it depends on the sort of substances.
yeah, of course.
You
And the exposure time you choose.
we can change the acquisition time, the number of averages, if you need to have quicker, yes,
or more accurate.
more accurate, you need to wait.
Yes.
And also, if you have mixture of with substances with low Raman activity, you need to you need to increase the acquisition time just to get a reasonable spectrum intensity. For example, glucose has Raman activity about order of magnitude smaller than aspirin. For this reason, you would waste some big spectrum of glucose just because they are not high enough to exceed the noise level sometimes. And if you are ready to wait, you can increase acquisition time and you get all of them.
Yes. And another question is about the steps that are the scanning settings. It is, I think, this software is for this device and for that device too, right? So when you set the setting, the parameters, I think just as I say, there's only how many steps.
But step size can also be set by user. It can for this task for recognizing of powders. It could be set by default to say 15 microns. It is enough to move from one particle to the neighboring one, but it should not be smaller than 5 microns, I would say, because average particle size is 5 to 10 microns. And that's why this parameter is still present in the software.
There's no problem when you are randomly scan this. But if you are scanning with this device, you just put how many steps. But I don't know how. Is it just like if there's 500?
Okay.
By 500, if it is 1 10 plus 50, or otherwise maybe 20, 25. I mean,
the coverage of surface doesn't matter.
Yeah, it doesn't matter, but it is not. It is.
I told you the step size should not be less than 10 microns, because otherwise you would measure the same particle several times.
Yes, but the coverage of the powder is may be limited. So in that case, I couldn't foresee if I got 1 times 500 and got like if this is a powder, this is the substrate, and 1 times 500 would be just like this.
Yes, and you would see just one particle.
Maybe 1 or 2 or.
But why are you asking this question? I told you it doesn't make sense if you want to cover a reasonable area with particles distribution. Normally it covers 1 by 1 millimeter for time like half an hour, and 1 by 1 millimeter is.
So the steps are distributed automatically. Square.
Yes, for this device they are distributed in square, or yes, even always square, not rectangular, because the number of steps in each direction is calculated as square root from the overall number, and if you are interested in the details, the start position of scanning is located in the middle, in the center of this square, of scanning square. And before the program starts scanning this square area, it moves from the central point, which which was chosen in the beginning, to the corner.
Okay. That's what
No,
it would be.
why are you drawing these spiral lines?
Okay.
The algorithm is a bit different, but it for the task of recognition of powders, it is all the same. It doesn't matter what trajectory was chosen, the size, and so on. The results are identical for both devices. Here we can see it by eyes. It is a bit more convenient to catch focus because you always see the laser spot. Here you don't have как это, окуляры-то?
Objective.
No, окуляры.
Окуляр, что за окуляр?
You don't see the spot in this device because and you just focus looking just on the signal strength.
Yeah. But you can always see the spectra if the spectra good is focusing
Yeah,
right.
exactly. That's why we don't need to enjoy laser spot shape, and it is enough to see the maximum signal and press start. And the software used for both devices is all the same. We only need to choose in these two settings and scanner device. It is either standard V6XY station called standard, and alternatively we could choose servo. Servo, it is called servo because it is controlled by two servo motors.
Okay.
The rest of software is all the same for both devices.